When it comes to metal corrosion, there are actually many different causes. For example, if there's a high level of dissolved oxygen in the water, it can react with metal pipes and components, leading to oxidation and corrosion. Another factor is high levels of dissolved solids in the water. When that happens, the conductivity of the water increases, and that can also promote corrosion. If the water is acidic, and especially when the temperature rises, the corrosion rate goes up even faster. And it doesn't stop there if the flow rate is too high, or there's strong turbulence, friction, or impact inside the pipes. That mechanical force can also wear down metal surfaces and lead to corrosion over time. When it comes to corrosion prevention, every water treatment provider may take a slightly different approach. Whether using chemical addition methods or other methods, the RSI index is very important. Now, take a look at this chart. When the RSI is between 6 and 7, the water is in a slightly scaling or slightly corrosive state, a sort of neutral zone. But when RSI drops between 4 and 6, the system becomes scaling prone to severely scaling. On the other hand, if RSI climbs to 7-9, you're entering corrosive to severely corrosive territory. Now here's an interesting question to think about. When water tends to form scale, is it more or less likely to cause corrosion? Or flip it around, when water is corrosive, is it still easy for scale to form? In practice, water treatment strategies often choose one direction to control, either toward the scaling side or toward the corrosion side. So if you were the water treatment specialist, would you prefer to keep the RSI in the scaling zone to prevent scaling? Or would you keep it in the corrosion zone to avoid corrosion? There's no one-size-fits-all answer. It really depends on your system, your goals, and what kind of treatment technology you're using. That's something worth thinking about.